scholarships are available. You may pick up copies at the steward's office or print them from your email. Due to our calamity days in the month of January and February, we will be extending our third quarter. Midterms will go home on Friday.
Great.
All right, on this, pick me a problem off the front of the page.
First, the hardest one.
Uh,
That's so the first one. 23.
I don't know paper, I'm just gonna write down what we did.
Pick me something other than 23, because I wouldn't mind if you missed that one.
Number one.
Number
14? Problem 14. I just didn't want to do number 1 again. I do it in every class.
Why not 23?
Yeah, it's got a negative. I might do that one also if you want to see it here in a minute. But that only works if you guys are helping me out so we can get through it.
Yes, sir.
Brighton's got to be quiet back here. Yeah, we're not going to get through it. He still can't. I say Brighton's got to be quiet. Then he talks right after that. I got to move him back up front, don't I?
Minus 12. I'm in a closet.
Minus 12.
Have a one-way camera so we can see out.
All right. On this, all you're going to do on this first part, since that leading coefficient is 1, if that's a 1 in front of there, it makes these problems where you're dealing with quadratics 1,000 times easier. If it's 5, 7, 8, whatever else in front, that's where it gets hard. You got to guess and check and go through all that extra stuff. But whenever it's 1, it makes it a whole lot easier. And all you got to do, draw your 2 parentheses.
Find the number that adds the 4 and multiply.
Right. First, let's find the factors of x squared. What are they?
X.
Peyton skipped over that because that's the easy part, right? We find the factors of negative 12. I usually draw this little T-bar almost like a 2-column proof here because we want them to multiply together to give us negative 12, whatever 2 numbers we pick. But we want them to add together to give us the middle term, which is a positive 4. So you want them to add together to give you that. Give me some factors of 12, negative 12, sorry, that we could try.
6 and 2.
6 and 2.
Negative 6.
Negative 6, 2. All right. What's negative 6 plus 2? Negative 4. Is that what we want in the middle?
No, so it's negative 2 and 6.
So negative 2, 6. Does that give us the positive 4? So those are the ones that are going to work, and we stick them in here. No commas, no nothing else. You're actually finding a mathematical term here, or mathematical expression, not putting a comma in there with coordinates or something like that. So it's x minus 2, since the 6 is positive, x plus 6. On the front side, that's all you have to do. Just factor. So on the front, you just factor. You don't have to go any farther than that. I'll do 23 just because it's a little different. This is one of them that it's a little harder because is your leading coefficient 1 anymore?
No, it's negative 1.
No, it's negative 1 now, and that sort of throws a wrench into everything. Now, if this was an equation, so if this was on the back of the paper, what I would do here is I would multiply everything by a negative to get rid of that negative 1 to make it easier on it. Since it's not an equation, you really shouldn't do that. We draw our parentheses. What are the factors of negative x squared?
Negative
And
X.
so one of them's a positive, one of them's a negative. Now we got to find the factors of positive 7. We want them to multiply together to give us 7, but add together, they should give us what? Positive 6.
I could not do it.
So give me some factors of positive 7.
7 more.
7 and 1. Anything else?
Negative 7.
Negative 7, negative 1. 7 and 1 combine up to give us 8. -7, -1 combine up to give us -8.
Well, -1,
Does this work?
no.
So the problem with this here, our leading coefficient wasn't what? It wasn't 1. So this adding them together to get that middle term doesn't work. This is the one, since that leading coefficient isn't 1, since it's a -1, or it could be 5, 8, 12, whatever other number other than 1, you just gotta guess and check. So we pick a pair of these factors, we stick them in here, and we use FOIL to check to see if it's right. Which pair do you want to try? You want to try the first pair or the second pair? First pair. So +7, +1. Does anybody remember what FOIL is?
First out, inner last.
First outer, inner last. Good. We don't really have to do all of FOIL because all we want to check is to get that middle term. So all we need are those middle terms really, outer and inner. We do the outer terms. What's -x times 1? -1x, good. What's 7 times x? What's a -1x and a positive 7x give us? Is that what we had in the middle?
Yeah.
So that means that's the factor 4. And having that -1 out there is just like having a 2 or a 3 or whatever. You would do it that same way. You find the factors, then you just got to guess and check. When you did factoring last year in algebra, probably everybody liked doing that when you first started out. Then all of a sudden you got to that next section, and they start throwing in stuff like 5x squared minus 3x plus 8,
I gave up on that.
and everybody gave up on it because they get hard because you have to guess and check. And with most teenagers, you make that first guess,
It doesn't work.
and it doesn't work, what do?
You
You quit, you give up. All right?
Come on, time for that.
never give up.
All right? So, if the leading coefficient is 1, should be real simple. Those are easy. If it's not 1, then those are the more difficult ones. And as you do them for a while, don't just give up on them. They'll get a whole lot easier. I'm going to leave off the 1 just because it's sort of unnecessary to be there. X squared minus 5x minus 36 equals 0. What's different on the back side? All right, you got an equation instead of just an expression. Corbin. I gotta remember which problem it was now.
850.
So I set up my parentheses. What's the factors of x squared? So we know those go there. What's the other term we gotta find the factors of? Close. -36. Since our leading coefficient is 1, they should multiply together to give us -36, and they should add together to give us what? -5. Give me some factors of -36. Corbin just dealt this out, so it should be easy.
It was like 9, I can't remember what the answer was.
9 and -4. Is that right? What's 9 plus a -4? +5. So is that the right pair? -9, +4, and that gives us the -5. So what goes here? X minus 9, X plus 5. That's exactly the same as on the front side of the page.
Isn't X plus 4?
X plus 4.
I don't know why I wrote 5. Sorry. That last class too put in some.
And then you put X minus 9 equals 0 and X plus 4.
And then all you do is split it up. You're multiplying these two sets of parentheses together. So one of them, to give you 0, one of them has to be 0. So you split it up. X minus 9 equals 0, or X plus 4 equals 0. How do I solve this one?
Plus 9.
This is the part that kills me. Are these real easy equations? When I did teach algebra, we'd get to this point and everybody'd look at it like, I don't know how to solve that. We had been solving problems like that all year long from the first day of algebra. These should be easy once you get to this point. Add 9 to both sides. X equals 9. How do I solve this one?
Minus 4.
X equals. When you're solving these with quadratics, anytime you have that x squared in any problem, you're going to have 2 answers. And what you're doing, what you're actually finding, if we were to graph it, is a parabola. Right? What you're finding when you're finding these 2 things, I didn't draw my parabola for this problem very well. When you're finding these 2 answers, you're figuring out where that parabola crosses the x-axis the 2 times. Right? So some of the problems, when you get them, I think there was one problem on here that came out x equals 7, x equals 7. Something like that. I don't. How many answers do you have there?
1.
Just 1. What do you think is true about the graph of that?
That's a straight line.
You did it wrong.
Yeah, you did it
It
wrong.
would be
That'll be a straight line.
It looks like this.
I don't like your math jokes. Oh, I remember that.
How many times does it cross the x-axis?
One time.
It only touches the x-axis once. So the parabola actually like sets on the x-axis. Here it crosses it twice. What if you came up with something and it wouldn't factor? You probably remember this from last year. I know my students remember it because I got some of them on this paper when I handed it out because they enjoyed writing it so much because they didn't want to factor anything. I tried not to even tell them the word, but then I had to. Prime. If something won't factor, then it's called a prime quadratic. That's what happens when, what's the parabola do when that happens?
Doesn't cross.
It doesn't cross.
Doesn't cross it anywhere. Alright?
So wait, some of the kids wrote that on all like.
Yeah, they just write them on every one of them. As a matter of fact, on this, that's probably the only thing they remember from my class, those certain students, because on the back page, they had prime on like half of them. And I'm thinking, you remember that from everything I taught you last year, or year before, whenever it
It
was.
was easy.
Exactly. Questions on 252? Problems you want to see worked off there? $29? Problem 29.
Right.
What paper?
Nothing. Nothing.
29.
I'm just going to draw the one triangle. Just the triangle we need for this part. It's the triangle that's there on the left. Somebody help me out so I don't have to hold my book. What they tell us about segment AJ? How about segment AK?
Hey,
Eight's the other one. Let's just go through here real quick. I don't even know which angles they're asking us about or anything. Which angle in this triangle has to be the biggest angle? Okay, so I'll just put a B in there. Biggest. Which angle has to be the smallest angle? A. Which angle is the middle angle then? Somebody give me the 2 angles that they gave us. Angle what? KAJ. And I'm going to draw this. Remember back to 3rd grade. Angle KAJ, AJK. Anytime you've seen that circle in 3rd grade, you knew to put what in it?
Alligator mouth.
One of the alligator mouths are an equal sign, right? Which angle is KAJ bigger than AJK, or is it smaller than?
Less than.
It's less than. So I put this symbol in there. On the test, It's just the relationship were confusing, which I sort of understand. Because they didn't know what's that mean? You know?
Yeah, that confused me, so I just guessed and did it like that.
Yeah, right.
Yes, right.
So I get things straight. Oh, on the test that you have next week, over this stuff,
No,
You said it last time. I know you
No.
said it. You said at.
the test that you might want to listen, test that you have next week over this stuff, there will be problems like this on there. And what I'll tell you right before the test, so that it doesn't confuse anybody and there's no confusion about which alligator mouth goes where and all that, I'll probably just say, tell which angle is the biggest. Or tell which one's the smallest.
Dumb it down.
Yeah, sort of. That way I don't have to worry about people saying, well, I thought that symbol meant greater than, or I don't have to worry about that. Which
Oh, that's the moment, really.
I know you should know that. But. Other questions on that page?
I used to draw my bird.
43.
43.
Click on-
Problem 43. Uh,
43. We didn't have to do 43.
that's right.
Oh, are you serious?
Corbin, did you do 43, 44, 45, 46?
No, I only did 43.
We
I did 43, not 46.
Oh, you didn't do 46? 46 is, that's the one I want.
Here, I'll go over this one. I might not finish it completely, but just to go over it real quick, because you should know how to do it. 43, give me just a second to, how could we figure out which of these angles has to be the biggest and which has to be the smallest? What might you do first? Distance formula, right? Find the lengths of the sides, then you can do all that. And I'm going to do that real quick. I'm not going to write down the distance formula. I'm just going to do it in my head here. -3 minus a -1 is -2. -2 squared is 4. -7 minus 5 is -12. -12 squared is 144, so that'd be 148. And I'm just going to write it this way. So this side is square root of 148. Whatever that is, it's 12 point something something. Whatever. This side, do we really have to, as I'm doing this, do we really have to find the exact lengths of each one?
No.
No, so if I just left it this way, are you going to be able to tell which side's the longer in the radical form?
Yeah.
Yeah, so if you're going any farther than that, then you're probably just wasting time. You're doing too much work. -1 minus 3 is -4 squared, that's 16. 5 minus 2 is 3 squared, that's 9. 16 plus 9 is 25. Square root of 25 is 5. This side, -3 minus 3 is -6. -6 squared is 36. -7 minus 2 is -9. That's 81. 36 and 81. That I might have to write down. 36 and 81 is 117. So that's square root of 117. Which angle is the biggest angle in this picture then?
Okay.
Okay, because it's across from the biggest side.
The next one's
The next one's L, so that's the middle angle, and which one's the smallest? So even though you didn't have to do that, is that something you should be able to do? Yeah. Draw a triangle.
PQR.
Now, did you have to put your P, Q, and R same place as I put them?
But I did.
Everybody knows that that's a Q.
P is 9 and plus 29. Q is 93 minus 5. And then R is 10n plus 6.
Now, my last class, I seem to forgot the one basic rule that we've covered here in the last couple months, which is what?
218.
3 angles of a triangle must add up to equal 180. So what equation? What equation can I set up?
9n plus 29.
I already heard the 9n plus 29, so we'll write out the long way.
93 minus 5n plus 10n plus 2 equals 100.
And if you combine that, it's 124 plus 14.
So 14n plus 124
Yeah.
equals 180.
14 equals.
Subtract 24 on both, or 124 on both sides. 14n equals what?
56.
Good. Divide by 14, what's in?
4.
Now I think that's part of the answer they wanted, but they also want to know which sides.
Which sides are bigger, so then you have to plug it all in.
Plug it in. Probably the easiest place to plug in is right here. What's 5 times 4? 20. 93 minus 20. 93
We should an R.
minus 20. We will here in a second.
Oh, it's 73.
73 degrees. 10 times 4. 40 plus 2. Now, we could just add those two together and subtract from 180 to get this one. Because my last class had to do this to figure out what
36 plus 29.
36 plus 29. What's that? So which side, what did they ask you on this one? To list them from what to what?
Shortest arm.
Shortest to longest. Which side's the shortest?
Oh, you can tell from the angles.
PQ,
So
right?
The shortest is side G, or not G, Q.
Where you got it?
Which one's the next shortest?
QR, RQ, whatever.
RQ, QR, either way.
Yeah.
And which side's the next shortest? PR is the longest.
And then you add them. I thought the lower number was just one above the lowest number, but then I realized it's
Guaranteed there's quite a few of these on the test where you gotta find this range. This is the easiest way to write it, I think. If you wanted to write it, I hate to even show this because as soon as I do, then people like mix the two together. But when they ask you the third side, if you wanted to write it out, you could write out like third side
I wrote S for side.
is between 6 and 16.
But we can write it out like that.
You could write it out like that if you wanted.
It's great as in.
See, I think this way is easier, and that's the only way I showed classes this year, because in the past when I've showed, write it out in words or write it out in math, then people get them mixed up and they try to put the things together, and then it's all confused everywhere. Other questions?
Actually, I'll just start it for you.
Which one? 14? Problem 14. Read the numbers to me, please, Brian.
1, 2, 3.
1, 2, 3. How can we tell if those can make a triangle or not?
You add the lower one.
All right, so pick two of them. 1 plus 2 should be greater than what? Is it?
No, it's equal.
So that one doesn't work, so what's that tell us?
No.
This is no, can't be a triangle. There's like 8 of those, that's the section I think I told you about last time. There's like 8 of them on the test, where you just got to answer yes or no, whether it's a triangle, whether it could be a triangle or not. Now, this one worked out nice because you guys picked the right ones. Does that mean if we would have picked 2 and 3, 2 plus 3 has to be greater than 1, does that mean it's going to be yes?
But you have to do every side.
You got to check all 3 of the different combinations of the sides. So don't forget that. Don't think
pick
that.
the lower number, like to.
And those are the ones that are probably going to mess up. But just to be sure. You're right. You can sort of look at it and say, which one of these aren't going to add up to be bigger than the other one, if any of them don't. All right, back to this. Let's go. Let's get it done. Perpendicular bisector, and I know I put these in a different order. This is the order the book had them in originally. Anytime you see perpendicular bisector, what things should you think of? What's perpendicular tell us? Right angles. So you might want to jot some of this in there. Anytime you see perpendicular, right angles. Somewhere you got right angles. You see bisector, what's being bisected on this one?
The,
The
angle
side.
and
Not the angles,
The side.
the segments, right? So you should think of congruent segments. Whenever you have perpendicular bisectors, know that you have right angles somewhere, you have congruent segments. So if I drew a triangle and I told you that that segment right there was a perpendicular bisector, you know that these two are congruent, and that's a right angle. And two, you should remember that perpendicular bisectors, unlike what I just did, don't have to come from a vertex. They're just that crazy line going through the triangle somewhere. Circumcenter. Guaranteed there's some problems on the test, and they'll say something like, point A is a circumcenter of triangle, whatever, and then it gives you a picture, and point A is right here, and you know it's a circumcenter, so then maybe you have something going like this. Well, what do I know about these two segments then? They're congruent. What do I know about these angles? They're 90 degrees. So you have to know those terms and what goes together. So I might not tell you that that line is a perpendicular bisector, but you should know it is a perpendicular bisector because I told you that point right there was a circumcenter. All right? So you got to know that that goes with perpendicular bisector. The circumcenter theorem. You have a question? Somebody have a question? Circumcenter theorem. If I tell you that point right there is the circumcenter, and that triangle, what the circumcenter theorem says, is that that point has to be the same distance from that corner as it is from that corner as it is from that corner. So all three of those distances have to be the same. And I'll write it out a little bit here. Circumcenter theorem just says circumcenter is equidistance. I'm just going to abbreviate that. Equidistance from corners of the triangle. Circumcenter is equidistance from the corners of the triangle. Anytime you know where the circumcenter is, the distance from it to one corner, it to another corner, it to the third corner, all have to be the same. We had another theorem that went along with perpendicular bisector. Run out of room. If I have this segment, and I tell you got some line that comes through it, and that line is the perpendicular bisector, any point that falls on that line is equidistance to each of the two endpoints. So no matter what point you pick that falls on that perpendicular bisector, it's the same distance from point A there as it is to point B. Medians. What should you think of as soon as you hear medians? Sort of. Give me a geometrical term. Midpoint.
Every vertex to the midpoint of the opposite
Side. So you should think of midpoint, congruent what? Segments. As soon as you hear median, no, hey, I got congruent segments down here on the other side, wherever it's at. If you hear centroid, you should think of all that same stuff. Centroid theorem, guaranteed there's a couple problems on there about the centroid theorem. And I'm just going to write something easy down here real quick. If that's our centroid, if that point right there is the centroid, this segment, you stupid thing.
Use markers.
Yeah, but then the people watching this can't see markers,
They can,
whoever these people are.
for one viewer.
Yeah.
That's right.
Hi, Rob.
You. Yes.
Be our officer.
That's a median. That points to centroid. And I tell you that this segment up here is 10. What do you know about this segment from here? 5. All right. So make sure you can do that. Remember, the theorem says this distance is 2/3 of the whole thing. Well, the easier way to think about it is from the vertex to the centroid is twice as long as the centroid to the midpoint. So if I gave you this one, drew that in there, and I told you this part over here was 7, how long is this other part? 14. You ought to set up equations from that also. Altitude. As soon as you see an altitude, what should you think of? Right angles. Gosh, she's got this stuff down. Right angles. As soon as you see altitude, right angles. Medians, congruent segments, midpoints, altitudes, right angles, perpendicular bisectors, all those things. For the point of, don't forget this word, point of concurrency. What's that mean again?
Where they all.
Just where they all cross, because I'm sure that that's on there somewhere, and somebody's going to say, what's concurrency? Point of concurrency for any of these is just that point, whatever that extra word is on each one, and for altitudes, it's the orthocenter. As soon as you see angle bisector, what should you think of?
2 equal angles.
All right, so I'm just going to write congruent angles. If you have an angle bisector, then you have congruent angles. In centers, where all those angle bisectors come together, the point of concurrency. I think, now that I think about it, I believe that the question on the test that I said was like this. It says point A is an in center.
You're using cursive.
Sorry. Point A is an in center.
You didn't say anything like the orthocenter.
Well, as soon as you, yeah, it's just the point where the altitudes all come together. We didn't really have a theorem or anything about it, so we didn't really use it a whole lot. If you see that this says in center, and I draw a triangle on here, and I do this, and that's point A right there, what can you tell me about these two angles here? They have to be congruent. Because if that's an in center, then each one of these that I drew in there has to be a what? Angle bisector. So,
Does that mean all the corners, is like sides of congruent?
so all these, each corner is being bisected. Each angle is being bisected there. If that's an in center, right? So what I'm trying to get at to make sure, do I have to tell you that you have angle bisectors? No, if I say in center, then you should know that that goes along with angle bisectors. If I say orthocenter, then you should know it goes along with altitudes and you have right angles. You got to know those terms and how they all go together. The two theorems. What was the other theorem? Was there two theorems that went with angle bisector?
Yeah.
There was? What's the first one? I thought there was only one.
Yeah, there's only one.
I don't know why I put down two. Maybe I missed one. Oh, well. Probably not like that. If I say that this is the angle bisector, and I pick some point on here, what do we know about that point? It's the same, this is sort of like the perpendicular bisector one. It's the same distance from the side of that, or that side of that of the angle, and that side. Those two sides have to be the same, or those two segments have to be the same. That's the other one that goes along with this. So if you know something's an angle bisector, and it doesn't even really have to be in a triangle. If you have an angle, and that angle's being bisected, well, my bisector doesn't look too good. You know that the distance from any point on it to that side is the same as it is to that side, so those two would have to be congruent to each other. And that works for any point, just like perpendicular bisector. Be able to compare angles and sides of triangles. Notice I did this just for Josh and Brighton. I said compare, not tell me the relationship.
Sweet.
I'm just kidding. Be able to compare them, tell which one's bigger, which one's smaller. Order them, biggest to smallest, smallest to biggest, whatever it says. Triangle inequality theorems. If I give you 3 numbers, tell me whether those can make a triangle or not. 3, 5, and 7. Would those work to be a triangle? Yes. Also be able to, if I just gave you 2 numbers, tell me the range. If I told you 2 of the sides of a triangle were 3 and 5, what's the third side got to be in between? How do you find the low end?
You subtract,
Subtract, and you get 2. How do you find the high end?
add.
Add them, you get 8. So be able to do both those things with those. Not a whole lot of information on this test because it only covered 2 sections. I shouldn't say that. There is a whole lot of information, but not a lot of different ideas like on most of the tests in here. All right, your assignment. This is page 274. This right here. This is page 277. That's to help you review for the test. I'm going to write some other things up here that you have to do. I don't know why this won't make a cube. There's the quiz that you were supposed to do last time on Moodle, the vocab quiz. And there's a second quiz now that I'm going to assign today on Moodle, and I think it's called Quiz Geo 1. So make sure you do both of those. You got the one done, then all you got to do is the second one. This is a 1 here, not a L. If you look on there, if you look on Moodle, right under the date, it'll have the notes. Then right underneath that will be that second quiz. So it's right there with today's date on Moodle. So make sure you have both those. The E-Day paper.
Wow.
It's just writing wherever it wants now. See if I can write over this way a little further. E-Day paper redo. If you wanted to get those points, make sure you redo that. Your test will be Wednesday. Don't forget to be writing down your theorems and stuff in your notes. And then theorem section of your notebook. If you wanted to do some of that, since we didn't have time in class the other day. And the other thing that I'll say to help you study, there's some videos on Moodle. If you look just down below today's date, down below the quiz and stuff, there's some videos talking about medians, altitudes, all that stuff. And the good thing about it is it's not me on the video, so you can watch something else. I think there might be some prettier teachers than me teaching it, so you might watch that. Sorry, Weston, none of them are in bathing suits or anything else, so you can't, don't think you're... So go on there, look at those videos that might help you. That's up to you. If you don't want to watch any of the videos, that's fine, whatever. But I put them on there to try to help you. So like 4 or 5 things there you got to make sure you have done. We'll